So the 8 steps, if we have a question like that, it's not on the quiz tomorrow. It's going to be on the quiz, I think, 4-4 or 5-4, 5-5. Is that Friday of this week or Monday or Tuesday of next? I think it's next Tuesday as well. All right. So if we do that, I'm going to give you all of the 8 steps because let's be honest, no one's going to sit here and memorize 8 steps. But I'll make it so that way you've only got, like, you can show me everything in individualized boxes. All right, so what we're doing today is just finishing up 5.3's notes, and then 5.3, at least to this extent, will not be on the quiz tomorrow. All right, so the first problem we're going to go over is one that you would see on a no calculator part 2 your test. Okay, so I might definitely mark that. It's supposed to be an N for non-calc active, but now do you guys want steps? Yes. So step 1 for a problem like this would be to go through and try to factor initially. So sometimes with a cubic you can use factoring by grouping to break it down and to get it into more workable pieces. So I always recommend trying that first. All right. So looking at this problem, can I factor it? No. So that's where steps 2 and 3 pop in. So step 2 is to create your list of all of the possible rational zeros. All right. So we did one like this last week. What are going to be my possible rational zeros? We remember how to do this from last week? Kayla? Leading coefficient. Yep. So it's factors of your constant over your factors for your leading coefficient. So we end up getting positive and negative, 1, 2, 3, 6. And then remember we had the duplicates. So really the only 2 fraction ones that we've got are 1/2 and 3/2. Madeline? Because we don't care so much about the negative here, because I'm going to hit all my positives and negatives here. All right. What are you thinking? So what are all the factors of 6? 1, 2, 3, 6. And then it's over factors of 2, so factors of 2 are just 1 and 2. So 1, 2, 3, and 6 over 1 are just my whole numbers. And then if I list all 4 of them with the fractions, 2 of them end up being duplicates. Like 2 over 2 is just 1. I already hit that. Remember? Nope, you were just testing me. That's fine. All right, ready for step 3? Everyone's favorite. Guess and check with synthetic division. All right. What are we looking for when we go through and do this? Yeah, no remainder. All right. Do we want to share the load a little bit? All right. Can you guys check positive 1? Can your whole row check negative 1? Can you guys check positive 2? Your back row, negative 2? Positive 3? Negative 3. Make sure you guys chat with your team. See if you guys are in agreement with what you got. All right. Anybody get a factor? You guys did? With positive 1? All right. So we're going to pull that positive 1. Synthetic. And I would add this in under the one that you've checked. Because in theory, you would have to go through and check a lot of these. Drop my 2. Bueno? It worked. Now, once you're done here, do you really want to go through and try to re-guess and check with this quadratic that we've got down at the bottom? No. So what you'll do is you'll start back over on your steps. Guess and check, get one down. Next step, go back and see if you can factor it. Okay? So I've got 2x squared plus 13x plus 6. I factor that. Just because you didn't like A being not 1. All right. So do you guys remember factoring by grouping? Or depending on who your Algebra 2 teacher is, they teach head, butt, gut, which is the same thing, but they just call it that because I think they butt, gut. So factoring by grouping is the actual name for it. All right. Multiply these two, and I get 12. What are factor pairs of 12 that will get me to 13? 12 and 1. Now it's come back? All right. Where we split it. So I've got 2x squared plus x plus 12x plus 6. What can I take out of those first two? Yeah, just an x. All right, what can I take out of these last two? I heard it, 6. All right, so I get x plus 6, and then I've got 2x plus 1. Are you guys okay with how that's my phone, don't worry about it. How do you guys feel about that? We okay? All right, now what was the expectation for this problem? What do they want us to do? Rewrite it in factored form. So I've got 2, I've got the one I pulled out earlier. So my answer for this is f of x equals x minus 1, x plus 6, and then 2x plus 1. Do I have to find the zeros? If it's not explicitly saying find the zeros, stop right there. Brendan. So remember the one that we did earlier? Did this, and it worked. Change your sign on it. All right. So that came from factoring right here. So remember, I pull an x and I pull a 6. Once I've pulled my x, I'm left with 2x plus 1, and then plus 6, and I should get 2x plus 1 here as well. Remember that? And then we just write one of them and take your 2 leading and put them back together. Bueno? Feel okay? What we playing? Surgery with a glue stick? Yeah. All right. Ready? So that would show up on a non-calc active part for your test because, let's be honest, all of those are nice, well, reasonably nice numbers. Yes? So here is the next one. Not so nice on this one. Do you have calculators with you? Because we're going to need it. Yeah. Right, we have this written down. All right, so as you guys are finishing up on writing it, I would start typing this into your calculator as well. All right, y equals want, I would put a little reminder up here that this one would show up on a Calc active part for your test. Because there really is no way without a calculator. And a lot of tiers. Well, think about it. It's degree 6. And how many factors of 84 are there? Yeah, way too many. So we kind of want steps again? All right, step 1. Graph it. Alright, and then we're going to go through and use synthetic division to divide out those zeros and get us something a little bit more manageable. Alright, so calculator-wise, should look a little something like this. Okay, we're all dying just at different rates. I would just hit zoom 6, because your standard window should be good enough. I don't know. I made it work. We're all having a bad day. It's Monday. Alright, can we see it now? Alright, so what do you guys notice about the zeros that I can see? I've got 2 that are at decimals, and those are going to kind of suck. But I have one at a nice whole number. Where is it? -2. What do you notice about it? What's the graph doing at -2? Which means what? Yeah, it's an even multiplicity. So I can take it out at least twice. Alright? So use that when we go through to do this. Alright? So, I'm going to take out a -2. And I'm going to do a giant synthetic division. 1, 4, run. I'll give you at least one whole number. I'm going to say that's way too mean. You forgot to put the 0 in when you did it. But now you did. Sorry. Need whiteout. Alright, so yes, you always need to double check and make sure there is not a 0, a missing term, when you do your synthetic. Otherwise, this is going to get really gross really quick. Alright, 1, -2, we got a remainder of 0. Okay. So we said multiplicity minimum of 2. So can I do it again? Yeah. So when I go to do my second round of synthetic division, I'm actually going to take all of the terms that I just got from that first round of synthetic division. Because let's be honest, if I plug it back in with the original, I'm just doing the same work I just did. So this is the polynomial after I've already factored out one of those zeros. So for this one, I've got something, but it's quadratic in form. Alright, so if you had me last year, remember we did U subs? Alright, so this is technically x to the 4th minus 4x squared. That's not a 2, that's a 2. Minus 21. Good God. This thing's got a case of the Mondays as well. Have you guys seen Office Space? Winter break homework. You're watching a movie. So there's this whole thing in there like someone's got a case of the Mondays. And it's really just about like office life in a cubicle. But that printer is officially dead. And there's actually a scene in it where they take a printer outside and they just kill it with a baseball bat. You will at some point in your adult life want to do that to any printer. Alright, so, can I maybe factor this? Yeah? So that's going to be our step 3. Once I've gotten rid of everything I possibly can, you're going to try and factor it. Alright, so those of you that I did not have last year, do you guys want to see the U sub method? No, why not? It is easy. So U sub is a calculus tool that we tend to use. So it's x to the 4 minus 4x squared minus 21. Basically, you use a U sub to get rid of things that are scary. Like, I'm going to say U equals x squared. So that turns this into U squared minus 4U minus 21. It just makes it so it's an actual quadratic, so it's not as terrifying. Alright, can I factor that? So, 7 and what? Which one's positive, which one's negative? So it's a negative 4, so my bigger number should be negative. Alright, so I've got U squared minus 7U plus 3 minus 21, and apparently I have to write slow because my poor computer can't handle it today. It doesn't really matter, because you'll end up getting the same factored form anyway. So I can take a U out of my first two terms, and I can take a 3 from here. And now I've got U plus 3, and then U minus 7. Little easier to work with. All right. Now for this problem, what do I need to do again? Yep, I'm going to have to get rid of the U and go back to x squared, but I just need it in factored form, yes? So, I've got my 2 from earlier. So, answer f of x will equal x plus 2 squared, because that was my multiplicity that I took out with synthetic division. And then I've got these. So x squared plus 3, x squared minus 7. Yes, no. As good as we can be for a Monday morning. Yeah? That's what we're going to do on the next one. Alright, so for this next one, we actually need to go through and solve it. But notice it's the exact same equation that we just worked with. Okay? So let's write this out real quick, and then we'll write in our factored form. Because let's be honest, if we've already done the work once, why do it a second time? So remember our answer from the last one. Now remember, when we go through to do this, we got to set each of those factors equal to 0. So I've got x plus 2 equals 0. So x equals negative 2. But remember, it's got a multiplicity of 2 on it. All right, now this middle term, I've got x squared plus 3 equals 0. Sorry. People listening to this are going to be like, oh my god, what just happened? Alright, what happens when I go through to solve this one? It's not real. So remember when we graphed it in our calculator, we had the touch, that's these first two, and then we had the 2 at decimals on either end. It's degree 6, so I have to have 6 zeros. These are my 2 imaginary ones. So I've got x equals positive and negative I square root of 3. Kind of remember? Mm-hmm. Yeah. Last one. So if I go to take the square root, I'm taking the square root of a positive, not a negative. I's show up when we take the square root of a negative. This is like beginning of Unit 2 from last year, so it's been a year since you've seen it. All right, do I have all 6 of my zeros? Yep. 4 real, 2 imaginary. The ones in purple are a little ugly, but we can still work with those. Alrighty. So for the most part, you guys have already written this down, yes? So the first one is just a theorem, and it says that for every polynomial function, if it's got real coefficients, so if all the numbers are in front of the x values, those are real, then we can factor it in some fashion, right? And we just showed it with the last one. It was degree 6, it was hideous, but it did have all real coefficients, so we were able to factor it down just a little bit. There's one more example after this, but we're graphing it, so don't panic. All right. The I can never say this word. Culinary. I want to say it like culinary, and it's in the wrong spot. This is basically like a little asterisk on a theorem. All right. It's like, FYI, if a polynomial has an odd degree, at least one of those has to be a real 0. Does that make sense? So at some point, it's got to hit the x-axis once, minimum. All right. Now, intermediate value theorem. Yes, we wrote this down and we're like, sure, I wrote it. I don't know what it means. So let's say you've got some polynomial, all right, and you've got A as 3 and B as 5. All right. When you plug these values into the polynomial, f of 3, let's say it is a positive number. F of 5 is a negative number. So 3 is a positive, 5 is a negative. That means that somewhere between 3 and 5, on my x-axis, I have a 0. I have crossed over my x-axis at some point. Now that I've written it out like that, does that make a little more sense? So think about it this way. F of 3 is just some positive y value. F of 5 is just some negative y value. It has to go through my x-axis at that point. Does that make sense? A little bit better? Okay. Now, here's our last problem. You need to find me the zeros, but you have to use the calculator. Do we know how to find the zeros within the calculator from a graph? Second trace, yeah. Did we get something like this? So make sure you know how to work the second trace. Number 2 is how we find zeros. And remember, it's going to ask you for a left bound and a right bound. So I need to be to the left of where I think that 0 is. Hit enter. And I'll get a little dotted line. Move my bug. Get another dotted line, and it'll guess. Did we get that? Okay. You want to make sure you know how to use this feature, because if you just write like 1.1, that's not going to work. Okay? You have to know how to use this feature so you can find the exact 0. Bueno? Kind of bueno? That's literally it. Just find the 0. Boop, there it is. Do we want to talk quiz for tomorrow and what all we've done so far? All right. So, first and third we went through. We made a list of everything we've kind of done so far. The Descartes rule of signs. When did we do that? Thursday? That was the one with the table. The positive, the negative, the imaginary, and the total. Right there. Do you guys want me to find a video and put it on the calendar, like an additional one? With some extra examples? Okay. Multiplicities, what they mean, what they look like. Write the equation given a graph, finding the zeros. We feel okay on that one? Alright. Possible rational zeros test, synthetic and long division, turning points, and the definition of a polynomial. We got anything we want to add to that? Yeah, you've got all of the different terms. Whole number exponents, positive exponents. Leading coefficients are all real in front of each term. No i's. That's about it. Anything you guys want to add to it? Brennan? Yes. Bueno? I think it's like 16 or 17. And you'll get a calculator, just not a graphing calculator. Bueno. Ohio State is coming third period, I think, tomorrow. Do you guys know if they're staying all of third and fourth or just third? I don't know. A bunch of third period kids said they'd signed up to see Ohio State, and I just wanted to make sure.